Welcome. Today we're diving into haptic heartbeat feedback. We'll be looking at a research paper titled Modulating Heart Activity and Task Performance Using Haptic Heartbeat Feedback, a study across 4 body placements. We're going to be exploring how vibrotactile feedback, mimicking heartbeats at different points on the body, can affect our actual heart activity and even our performance on mental tasks.
That's fascinating.
It really is. Imagine feeling a simulated heartbeat could potentially influence our brains and bodies as if it were our own. Have you ever considered how your heartbeat changes when you are stressed or excited?
That's a great example of a concept known as interoception, which this study explores in depth. Interoception is our awareness of internal bodily sensations. It plays a crucial role in how we perceive emotions, make decisions, and even form memories.
This concept of interoception is fascinating. The study mentions somatic markers. Could you elaborate on what those are and how they relate to our emotions?
Certainly. Somatic markers are the physical sensations associated with our feelings. Consider the familiar experience of a racing heart when afraid, or a sensation of butterflies in your stomach when anxious. These are examples of somatic markers. The study posits that these sensations, coupled with our past experiences, contribute to a feedback loop that shapes our emotional responses.
So
Essentially, our bodies provide us with cues to interpret and react to situations.
So these researchers are creating what they call interoceptive illusions, essentially attempting to manipulate our interoception. How do they achieve that?
Researchers have discovered methods to generate these illusions using visual cues, sounds, and even touch, which is the focus of this particular study. This is referred to as haptic feedback.
Okay.
Envision a vibration that simulates a heartbeat. That is haptic feedback, crafted to create an interoceptive illusion.
So the central question is, where on the body is the optimal location to deliver this haptic feedback for maximum impact? The researchers examined 4 different pulse points. What were those specific points, and why were they chosen?
They selected the chest, wrist, neck, and ankle. These locations were chosen for their accessibility and suitability for integration into wearable technology. They also correspond to areas where one can readily detect a pulse. The objective was to determine if stimulating these areas with a simulated heartbeat could influence the actual heartbeat.
They equipped participants with these heartbeat simulators and engaged them in a mental task to occupy their minds. What sort of task did they employ?
The study utilized an NBAC task, a commonly used assessment of working memory and attention. In this task, participants are presented with a series of letters and are required to press a key when a letter matches one seen a specific number of steps back in the sequence. It's similar to trying to recall items on a grocery list from memory.
While participants were engrossed in this cognitive challenge, they were simultaneously experiencing a simulated heartbeat through the haptic device, either at a slow pace of 50 beats per minute or a faster pace of 110 beats per minute. Let's move on to the outcomes. Were they able to alter people's genuine heart rates with this artificial heartbeat?
They were, in fact. And here's where the findings become particularly noteworthy. The placement of the device played a significant role. The neck placement resulted in the most pronounced increase in heart rate, especially when the faster 110 BPM frequency was applied.
So stimulating that sensitive region on the neck can indeed accelerate our heartbeats. However, was it a comfortable sensation for the participants?
Not particularly. Participants indicated that the neck placement was the most distracting and least pleasant. It appears that sensing a simulated heartbeat in such close proximity to one's actual pulse can be somewhat unsettling.
That's understandable. What about the other placements? Did any unexpected observations emerge?
The ankle placement produced some intriguing results. While not as effective as the neck in elevating heart rate, participants barely registered the feedback there. This suggests that the ankle could be a discrete location for delivering these interoceptive illusions, influencing us without our full awareness. This leads us to consider the implications of these discoveries. The realization that we can affect our physiological state through touch, even without conscious recognition, is a profound concept.
The notion that our bodies could be subject to manipulation in this manner does give one pause. Do you envision any beneficial uses for this technology?
That brings up an important point. While the study concentrated on the scientific aspects, it is not difficult to envision how this type of haptic feedback might be employed in various fields.
For instance, could you provide us with some examples?
Consider the realm of virtual reality experiences. Imagine a horror game in which haptic feedback escalates as you draw near to a fearsome creature, elevating your heart rate and amplifying the immersive quality of the experience.
That would certainly heighten the fear factor. I can see how that would enhance the entertainment value. But I presume there are more serious applications as well.
In the field of healthcare, this technology could be utilized for biofeedback therapy, assisting individuals in learning to control their heart rate and manage stress, or even as a treatment for anxiety disorders.
So rather than merely tracking our heart rates with wearable devices, we could potentially use them to regulate our heart rates in real time.
Precisely. The potential exists to develop personalized interventions, tailored to an individual's specific requirements and responses.
What about utilizing it to enhance performance? We observed that faster haptic rhythms accelerated response times. Could this be employed to assist athletes in training, or even to give individuals an advantage in high-pressure circumstances?
That is certainly an area worthy of exploration. Consider surgeons or pilots, professions where maintaining a composed and focused state is paramount. Perhaps haptic feedback could be implemented to help regulate their heart rate and optimize performance.
However, as with any potent technology, there are ethical considerations to address.
Undoubtedly. We must proceed with caution in the development and utilization of this technology, particularly in light of the findings related to the ankle placement, where individuals were largely unaware of the feedback, yet still exhibited physiological changes.
The potential for subconscious manipulation is a legitimate concern. Open dialogues and the establishment of clear guidelines are imperative to prevent its misuse.
Transparency and user consent are of paramount importance. Individuals must be informed about the mechanisms of this technology and retain control over its application. Imagine a scenario in which advertisers or political campaigns began employing haptic feedback to subtly sway our emotions and decisions.
That is a disturbing thought. It's akin to a real-life manifestation of subliminal messaging. But instead of visual or auditory cues, it directly taps into our physical sensations.
This underscores the need for responsible innovation. We must anticipate these potential drawbacks and develop safeguards to ensure that this technology is used ethically and for the betterment of individuals and society as a whole.
There's much to ponder. This deep dive has certainly provided me with ample food for thought. I am still grappling with the fact that a simple vibration on my wrist or ankle could exert such a profound influence on my body and mind.
It challenges our comprehension of the interplay between our physical and mental states, and it unveils captivating new possibilities for how we interface with technology.
Speaking of captivating possibilities, there remains one more fascinating aspect of this study to examine. The researchers did not limit themselves to measuring heart rate and task performance. They also investigated how individuals perceived these haptic heartbeats. Let us delve into those findings in part 3 of this deep dive. Let's shift our focus to the more subjective aspects of this research. How did people actually perceive these simulated heartbeats?
This aspect of the study delves into the qualitative experiences of the participants. It explores how they felt and reacted to the haptic feedback.
The study references terms such as autotelics, harmony, and immersion. Can you clarify what these terms signify within this context?
These terms are derived from a questionnaire specifically designed to assess haptic experiences. Autotelics pertains to the inherent enjoyment and satisfaction derived from the experience itself.
Okay.
Harmony describes the degree to which the haptic feedback aligns with the user's actions and intentions. Immersion refers to the sensation of being fully absorbed and mentally present within the experience.
Did participants derive enjoyment from sensing these artificial heartbeats? Did it feel natural or incongruous?
The results were not uniform. Participants generally expressed a preference for the slower 50 BPM haptic frequency.
Okay.
They perceived it as more pleasurable and harmonious. They also rated the chest placement as the most harmonious, indicating that sensing the feedback in that location felt more congruent with their overall experience.
The neck placement, however, was the least enjoyable, correct?
That is accurate. It appears that perceiving the feedback in such a sensitive area, in such close proximity to the actual pulse, was perceived as less agreeable and more distracting.
What about the ankle? If we recall, that was the placement where participants were minimally conscious of the feedback.
While the ankle was not the most enjoyable placement, it was not the least enjoyable either. This supports the notion that the ankle could serve as a location for more subtle and potentially less intrusive haptic feedback.
To summarize, the chest emerges as the most harmonious. the neck as the most distracting, and the ankle as the most discrete.
That is a concise and accurate summation. It underscores the importance of placement when designing haptic feedback systems. The location on the body can significantly impact how the feedback is perceived and experienced.
This deep dive has been truly illuminating. It is remarkable to contemplate the subtle ways in which technology can influence us, even without our conscious awareness.
As we continue to integrate technology into our lives, it is crucial to remain cognizant of these subtle influences and to advocate for responsible and ethical design practices.
We can all agree, I believe, that we would not wish to inhabit a world where our emotions and decisions are manipulated by concealed haptic feedback.
The trajectory of technology rests in our collective hands. It is our responsibility to shape it in a manner that benefits humanity.
As you navigate your day, dear listeners, take a moment to reflect on the technology you engage with, from your smartwatch to your phone. Could those vibrations be serving a purpose beyond mere notifications?
Awareness constitutes the initial step toward making well-informed choices and shaping a future in which technology serves us, rather than the converse.
This concludes our deep dive for today. Thank you for accompanying us on this exploration.